This video is part of our series on how to solve trig equations. It will highlight one strategy for solving equations, how to use it, and how to know when you can use it. The strategy highlighted in this video is called isolating a single trig function. This is the most basic way to solve an equation, and so it's the most widely useful. If you're going to do this strategy, you should be looking at an equation where there's only one term that has a trig function in it. And that's true of both of the examples that I'm showing on the right. Number 1 has a secant in it and all the other terms are numbers. And number 2 has a tangent in it and all the other terms are numbers. It doesn't matter that the tangent is squared, that still counts as one term. What I'm looking for here is that, for example, number 2 isn't tangent squared plus cosine squared equals -1. That would be two different trig functions in that equation. So now we will use those two problems as our examples of how to use this strategy. So basically, this strategy is exactly what it sounds like. If we want to find the solutions to root 3 secant theta plus 6 equals 4 on the interval 0 to 2 pi, the first thing we need to do is isolate the trig function that's in the equation. So in this case, that means isolate secant theta. And I'm going to do this just using normal algebra. I'm going to think of secant theta like an x that needs to be by itself. I'm going to subtract 6 on both sides and then divide by root 3. This is going to give me secant theta equals -2 over root 3. So once I have the trig function alone, then I'm free to ask, okay, what angles have the secant -2 over root 3? Since secant theta is a reciprocal function, a lot of people prefer to think of the original function that goes with it, cosine. So you can rewrite this by changing the secant to a cosine and flipping the trig value. So write it as cosine theta equals -√3 over 2. And then you have to say, what angles have a cosine of -√3 over 2? This is just a little bit more familiar to a lot of people, but if you think it's fine to use secant, go for it. The reason that it was so important to isolate our trig function is now that we know that cosine theta equals -√3 over 2, this tells us a lot. For example, just knowing that the cosine is negative tells us our answers have to be in quadrant 2 and quadrant 3. So I've drawn these two little green lines on my diagram to help me visualize my solutions. Second, because cosine is adjacent over hypotenuse, I know my adjacent is root 3 and my hypotenuse is 2. From special right triangles, I know this must be talking about the 30, 60, 90 triangle, and since the adjacent is root 3, the opposite has to be 1. 1 is across from pi over 6, so that's my reference angle. Reference angle of pi over 6 in second quadrant is going to be 5 pi over 6. Reference angle of pi over 6 in third quadrant is going to be 7 pi over 6. And so I can write my two final answers. Theta equals 5 pi over 6 and 7 pi over 6. In our second example, we'll do basically the same process, but with a little twist. In this problem, we'll start by isolating tangent of theta. So I'm going to add 2 to both sides, and then because tangent is squared, I need to take the square root. The really important thing to remember here is that because I'm taking a square root, I need to have a plus or minus in my answer. That plus or minus is a big deal because since tangent can be either +1 or -1, that means that my answer is going to be in all 4 quadrants. Remember, when tangent equals 1, it's not on an axis, it's actually the pi over 4 reference angle. And I know it's pi over 4 because the only way to get a tangent of 1 for opposite and adjacent is having those be equal, and that's what happens in the pi over 4 reference triangle. So then, finding the 4 angles that I drew with a reference angle of pi over 4 in each quadrant gives me my final answers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I just want to end with one little reminder not to forget about quadrantal angles, or the possibility that your answers could actually end up on an axis. What I mean is, what if you had an equation that had sine theta in it, and after you got sine by itself, it was equal to -1. Sine is only going to be equal to a 1 or a -1 on one of the axes. And since sine corresponds to y, you want to look at your axes and say, okay, that's on the negative y-axis or at 3 pi over 2. Happy solving! Make sure you check your reference sheet as you're practicing finding reference triangles, and don't forget, if you take a square root, you need plus or minus in your answer.